Yeah, thank you for inviting me to this occasion here. I'm talking at the Imperial College about the development of lifecycle inventory data for the oil and gas sector and the experiences, the actual data on the one side and the experiences, how this developed over 30 years. The presentation I'm giving is also based on a lot of work my colleagues, Christoph Meili and Marisa Busser, have done at ESU-services, and yeah, that's about the presentation. So here also you see the faces of the different people working at ESU. We are a consultancy specialized in life cycle assessment. We worked on more than 400 projects in the past 25 years for all types of clients, and we developed also a company-owned database with more than 10,000 data sets. And well, our main activities are consulting in the field of lifecycle assessment. This means we are doing case studies on lifecycle assessment, carbon footprints, EPDs, and PEF studies according to different standards. We are selling software, the SIMAPro software, in the German-speaking market, and develop, for example, automation and key parameter models based on the software. We are also active in providing background data for lifecycle assessment, mainly the ecoinvent database and other databases. And we provide training and coaching in this field, and also peer reviews, verification, and validation. Today, I'm reporting about these developments for the oil and gas extraction over the last 30 years. Here is a list of all the major work we have done in this field. Well, in Switzerland, LCI, as it is seen today, started with the Ökoinventar von Energiesystemen, the first complete database with lifecycle inventory data developed at the ETH Zurich. I myself was not part of this team. During the same time, I worked on a lifecycle assessment of kerosene and liquefied petroleum gas in India for cooking. So I already there dealt with the oil and gas sector. Then in the years 2000 to 2007, we worked on the first versions of the ecoinvent data, which were a translation of the ecoinventar into a new data format and an update of the existing data. At this time, the reports were written in German for Erdöl and Erdgas. And since 2018, we have worked on for several funding parties also on updating again these data, which haven't been updated for 15 years. It started with the work for the Swiss agencies. Then we also worked for ecoinvent, and today we are also providing data for the CarbonMinds database. This work is ongoing, so in the moment we are again updating the data for oil and gas extraction in several countries. What I present here today is my personal summary of all this work, so it's not related to the work of a specific funding agency or so, and we are just presenting our own views or points of views. Well, I start a little bit in the middle of this journey because it's more the actual theme, the update we started in 2018, where major update has been the update on methane emissions, which many users recognize because the global warming potential increased. This work has been first been funded by the Swiss agencies, as I said, and Swiss oil and gas associations. And the data were fed into a version of the former ecoinvent database, the so-called FÖN database, which is used in Switzerland. I directly start with this important question of methane emissions. In the data before, there were only rough assumptions. We know that there are methane emissions on the one side, well, that there's flaring of gas and then the methane is burned, but you have also the so-called venting of gas at installations in oil and gas extraction. because in times of there is not enough production taking place or so, methane is just released without burning it. But then in these years, it has been discovered by satellite measurements that there are other unwanted releases of natural gas in the process chain, for example, due to leakages, insufficient flaring accidents, and so on. And a part of the methane even might come through the soil, for example, during fracking processes. And the important change that has taken place was these satellite measurements that had been done, because before, if you just rely on what you can measure at a stack or at a technical system, you are really bound that you know the source of the methane, but the satellite measurements showed that the methane emissions are much higher than what has been recognized before. And they are not directly connected, for example, to technical parameters like the flaring rate or the venting that is known by the industry. The satellite data are available for all types of emission sources. They can differentiate between fossil and biogenic methane emissions, for example. They can locate the exact place where the emission takes place, and so it's possible to relate it to certain installations of the oil and gas industry, like pipelines or extraction wells and so on. It's also possible, for example, to distinguish between onshore and offshore emissions, and as I said, the upstream and downstream emissions. There are different research groups and publishers who have published such data. From version to version, we relied on also different sources and combined different sources for such data. Here's the first table, which shows the switch or the change that has been observed. So the industry, the IOGP data, which have been reported since quite some time, they are just based on the onshore measurements, I would say, so on the known releases, for example, due to venting. But the satellite measurements, they are about a factor 10 higher than these emissions known so far. So that was an important switch. The vented natural gas, of course, it's mainly methane with a very high global warming potential, 30 times higher than the CO2. And so it makes a huge contribution to the global warming effect. Here we compare from this first study, we compared the new data with the, at this time, existing ecoinvent 3.8 data. We see that this emitted natural gas now can have a major contribution to the carbon footprint of the oil or gas. This is for natural gas extraction. For the natural gas extraction in different countries, we also see that there might be huge differences in the overall carbon footprint and in these methane emissions, because oil and gas extraction is not such a standardized technology. It depends very much also on the conditions under which the oil is extracted. For example, normally in the Middle East countries, it's much easier to get the oil than in other countries. We also see that conflicts play a role, like the Libyan data, they are very high, which might be also, or a reason might be that at this time, the political control and the technical control of all these extraction facilities was very weak. And another example, like in Norway, where you have good control of emissions, normally these methane emissions are much lower. So it depends also on the political circumstances in the different countries. And you see that, in this study, we discovered that the former assessments normally were much lower than the new assessments we did. Of course, for this study, we not just took into account the methane emissions, but all other emissions and processes like flaring natural gas. We also have like global databases, but also burning and energy provision for the oil and gas extraction is included, of course. Also, the well drilling is included as an activity where you need also energy carriers to make these activities, and these are the other emissions. Well, at this time, we also checked which influence might be expected for plastics data. So on the one side, of course, these fossil resources, they are used as mainly used as energy carriers for all types of fuels, for burning and transportation. These upstream emissions normally do not play such an important role if you take into account the full life cycle of the fuel. So if you burn the fuel at the end, of course, the carbon, or the highest share of the carbon footprint is due to the burning of the fuel when the full amount of CO2 is released. Only 10–20% of the emissions are then due to the upstream activities like the extraction of the resources and the refining and transportation of the resources. But for plastic data, where at the time the plastic is sold for cradle to gate analysis, of course, where the plastic is not yet burned, this plays a larger role. The challenge for this was that the Plastic Europe's data at this time were partly available only in aggregated form, so it was not possible to make a unit process-based modeling of these plastic chains, but we had to apply these changes also to these system processes. We made an estimation of these surplus methane emissions based on a rough estimation per kilogram of oil or crude oil that has been used in the life cycle, and the cubic meter of natural gas. So we applied an additional factor to the plastics data in order to see which relevance this has for the plastic data. And this we imported to our ESU database. We see that, well, here the old system processes, or the old processes provided by the database, and we see the new estimation with the methane in the KBOB or ESU data, where we added these additional emissions. And so for the plastics at the gate of production, this can increase the carbon footprint by 15 to 30%. Yeah, and this we also integrated in the ESU database. This is the results for all types of plastics. So always compared the KBOB data where the factor has not been applied, and the ESU data where the factor has been applied. And so we see the increase of methane emissions when we integrate this in the plastics data. Plastic Europe also get aware of this issue. Well, I think I presented this first in 2019, and they directly asked me about this, and I made a presentation for them. So they organized a workshop, what it means for them and how they can address this issue. Today, but the problem is a little bit that for the Plastics Europe data, they work together with different consultants using different background data. So they work together like with the EFOI from Germany and Svera, formerly known as Gavi or E. So they started including these methane emissions. For example, this data we later on integrated in ecoinvent. And so step by step, they are updating the data. And at least the newer data, which have been provided, for example, by the EFOI Institute for Plastics Europe, address this issue of unintended methane emissions today. Yeah, now I also come to the latest modeling we did. As said before, we worked for different commissioners, and we first integrated this data also in ecoinvent 3.9, 3.10, and now 3.11 has been released with updated data. So each time we updated the major key factors and the changes in the market data. And we also work together with CarbonMinds. Yeah, as I said, the ecoinvent data 3.11, they just have been released, and there we updated again the market mixes with the reference year 2023. So you always need some time to integrate such data in a database. We have now established processes how to make this as fast as possible, but we first have to wait for many statistical data, which are published by different organizations like BP or IOGP and so on. And so we only can start maybe at the end of or after the mid of the next year with starting with updating the LCA data. And so we were able this year to publish the data with the reference year 23. And well, a lot of work is, of course, also documentation of this data in the data sets. And more we are covering the global market situation. So the first studies were mainly related to the Swiss situation, where we made specific supply mixes for Switzerland and Europe, and this coverage has been extended more and more to the global situation. And well, today for the extraction, we cover all the countries marked here in blue. So really covering 96% of the global oil and gas production in 49 countries. We also established markets for crude oil. So, of course, the next step is then bringing the crude oil to a market and then mainly feeding it to refineries, for example. And then, for example, we have a lot of refineries in Europe, for example, in the Netherlands, and they are importing oil from different countries by by ships, and where you have German refineries, for example, which were connected to the Russian supply by pipelines and so on. So these market mixes take into account these supply situations of crude oil and natural gas to the different countries. And what is also, of course, relevant is that these markets changed a lot due to the attack of Russia on the Ukraine, and Europe stopping importing or tried to stop imports from Russia. So they changed to different supply sources, and on the other side, the Russian oil and gas was supplied to other countries which are not taking part in boycotting these supplies. Well, these are the markets we modeled for natural gas, mainly the industrialized countries, 15 countries now today, and for the next update for CarbonMinds, this will be further extended. Well, of course, it's not possible to update each and every number in these updates. We mainly focus on the market situation, which means the production figures of oil and gas in the different countries and the trade figures for the two resources between the different countries. Also information about how it is traded, especially for the natural gas. It makes a difference if it is transported by ship as a LNG or if it can be transported by pipeline. We updated these methane and flaring emissions. For these latest updates, we used data by the International Energy Agency and the World Bank. We have the International organization of oil and gas producers, which also have an environmental reporting about key figures on energy, fresh water, and other key indicators, which we integrate in these updates. Yeah, then we measure the pipeline distances, of course, with Google Maps and the shipping distances. And so at the end, we derive the market mix for the supply to different countries. For doing this work, we use a huge Excel table where we copy in all the data. The challenge is that while the data sources change from year to year, there's a nomenclature changes in these data sources and so on. So still some manual work is necessary in order to integrate the newest data in our tables. And an automatic import, for example, is not always feasible because of these changes in the structure of the information. But well, we have refined this very much and can export the data then with macros from Excel to the formats like EcoSpolt or the ecoinvent format, so that we can provide the data to our customers. Here again, some exemplary results for the natural gas and the changes we see. Again, we see this huge rise in methane emissions due to the emitted gas. If you compare the ecoinvent 3.8 data before all these updates and the 3.10 data, we see these changes, but it's not linear changes because there also have been a lot of updates on the one side of the mixes and the energy uses in the life cycle. But in general, we see this emission, again, this increase in the carbon footprint of the oil and gas. Well, we think that we achieved a very high level of data quality already with this by combining on the one side the industry data, but also including scientific data, published data by international organizations and so on. We try to be consistent with these international data sources and use them as much as possible. On the other side, this also means that for these data which are not reported annually, of course, it's more and more difficult to update them, like the heavy metal emissions or the water pollutants or water use. Especially, it's hard to find actual data. Well, we think that these top-down statistics deliver a very good picture, and we not, bottom-up data are much more difficult to find in such a complete and accurate way. But we use bottom-up studies, of course, to make certain assumptions, for example, on pipeline use or use of chemicals. Well, the data can be found on our web page or the reports for the data. And just today I uploaded the reports for 24. Good. Now I will come a little bit to the history of modeling these life cycle inventories and the changes we see in the way how we establish such inventories. The first step were these first LCA databases, like the Öko-Inventare von Energiesystemen, and my diploma thesis, for example, which worked in the same way, was not such an extensive work, where I worked in India. So the estimates were partly based on bottom-up approaches. We combined different data sources. At this time, we had very detailed emission figures of measurements done at universities for all types of heavy metals, for all types of carbon emissions to air and soil and water. Because at this time, I think all these universities, they had new nice measurement devices and they could test them on all types of substrates and emission sources. This also was the foundation for this very comprehensive inventory of pollutants, for example, in ecoinvent, where we have more than 1,000 different pollutants differentiated in detailed emission profiles, for example, for single NMVOC. Well, the literature sources at this time they're in printed format. So from India, I took away about 30 to 40 kilograms of paper when I went back home to write my diploma thesis. Well, we need the direct contracts, for example, with refineries and oil extracting companies and asking them for data. And we didn't have any electronic documentation of such numbers. Then in the update for 2000 to 2003, we had more environmental reports of single companies. On the one side, this was a nice new data source because companies started measuring and reporting such environmental data on their own. But they focused, of course, more, for example, on energy use and main pollutants and did not do these extensive measurements of all types of pollutants. Sometimes it was also difficult to use these environmental reports because of different system boundaries, because these oil companies, they are sometimes integrated for different countries or for different steps of the production chain, like extraction and refining and so on. It was not so easy to differentiate this in the way of unit processes. So we had to combine these different data sources. And then we also used a more extensive format for data documentation, of course. Then for this next chain of updates, much more you could use information available on the internet. Nothing is printed anymore. So it was also possible to download big tables and so on with a lot of data from global statistics. We find mainly information for the European situation, but not so much information anymore for example, Africa, Russia, and Middle East, where you do not have such an open way of publication of data. Well, the reports of oil companies, for example, or in general, the environmental reports of companies are of less usage, I would say. They are not reporting anymore such detailed data we need for life cycle assessment, and we cannot use them anymore. And the focus is more and more on the main air pollutants like CO2, NOx, SOx, and nothing can be found on all these heavy metals, single NMVOC or water pollutants we had in former versions of the database. So often still these detailed emission profiles are based on very old measurements, which have been, of course, we tried somehow to update them, for example, by the total amount of NMVOC and integrate this somehow, but these detailed emission profiles are not available more because it's not of interest for universities anymore to do these measurements, and the legal situation doesn't force companies to do such measurements. Well, for the latest updates and for ecoinvent CarbonMinds, we used again these global annual statistic and satellite measurements. We set sometimes specific themes. For example, we try to find out more about the water balance in oil and gas extraction, which is a little bit complicated because oil is mixed with water. So we are taking up fossil water. You are pumping down water into the soil to make, for example, fracking or press out the oil. You are releasing water to ocean or to rivers. You're cleaning the water and so on. So it has to do a lot of this water, but not much is reported about all these water flows. And for this water footprinting, it's quite a problem to get the information about all these water inputs and outputs you have. And it's also for the water footprint a little bit specific problem. Well, if this houses water contributes to water scarcity, for example, there might also be situations like in the Middle East where you pump up more water with the oil and release it to the environment, which might be a beneficial effect because you have water, but on the other side, the water is polluted and might not be so suitable for plants and the nature. Okay, and then of course we had quite a focus in the last years on all these market shifts, mainly due to the Russian attack on Ukraine. Yeah, this is the situation. As I said, the reports are available here under these links. It's also important to mention maybe that the UNEP has now the so-called International Methane Emission Observatory, which coordinates the different activities. These methane emissions are low-hanging fruit. On the one side, they have a really relevant contribution to the climate change effect. In principle, it would be easy to avoid a lot of these emissions by identifying the sources of emission better. And if you know by satellite measurements exactly the place, you have to go to this plant and you have to identify it on site, for example, the leakage in a pipeline or something like this. And so you can make a contribution to reducing these emissions. And they are, of course, very much relevant because of the short-time effects. And so in the next 20 years, our fate for the climate crisis will be somehow decided. And at this time, these methane emissions are very relevant, or much more relevant if it takes the global warming potential for 20 years into account. And this UNEP tries to coordinate the activities to reduce these emissions and to monitor them, of course. Well, so in summary, can be said that the methane emissions have to be covered in life cycle inventories of oil and gas. It's not sufficient just to take the data reported by industry, and because they don't give a full picture, the industry cannot measure these data on ground or at place. The changes are mainly relevant for the cradle-to-gate analysis of products made from fossil resources like plastics and chemicals, because if they are not yet burned and the carbon is still stored in the product, of course, these upstream emissions are much more relevant. At the end, these changes are also relevant for relative comparisons between fossil-based products and bio-based products, because it increases the carbon footprint of the fossil-based products and gives a higher advantage for bio-based products. And as I said, it's these regular updates and of course are necessary to have an actual picture. As said before, the data are now integrated in ecoinvent, fully integrated in ecoinvent, CarbonMinds, ESU, and FIN databases. They are partly integrated by Plastics Europe, but there are other organizations, and as far as I know, they have not fully integrated them yet. Stera, the provider of the Gabi, called today ACA for Professional Database. And to my knowledge, at the first meeting, they said that they would like to rely on the industry data and not take into account this more scientific data. I'm not fully informed about the status. As far as I see, they are also not yet integrated in the IOGP data, but we had discussions with these organizations that it would be good and necessary and relevant to integrate it. And there might also be industry associations, for example, like Eurobitum, which have not yet integrated this in their public inventories. And so, of course, it's might be a very relevant difference if you look at such data and the ecoinvent data in comparison. And with this, we also see that it takes time to integrate such knowledge in databases. Today, we have 2024, so 6 years ago, we integrated it for the first time in ACA data. Of course, the satellite measurement even might have been taken a few years ago. So it is now a long way to make this knowledge really integrated in each and every source of carbon footprint data, I would say. And so data quality really is an issue in all these databases available today, and in the, of course, that you find so many data published and not always takes the news data available. Yeah, this again, the key messages. I think I like to repeat too much. The consumption mixes are relevant. That's for the natural gas, of course, there's some discussion about this LNG imports, for example, to Germany. LNG has a higher impact due to the transportation, due to the pressurizing and depressurizing of the gas. On the other side, there are other effects, for example, like the mix you have, and which also play an influence. So it cannot be said in general, for example, that the natural gas in Germany is now much worse because of these LNG effects or LNG imports. And so LNG is just one factor in this total picture. Yeah, for the natural gas, the effect was less pronounced than for the crude oil because of higher other downstream emissions. And as I said, it's mainly relevant for materials and to a lesser extent for energy uses. Well, what will the future bring? Oil and gas is a dying industry, hopefully, I would say. So we should manage to stop all extraction of oil and gas in the next 20 years. It's clear from a climate change or climate crisis point of view. So, of course, situation will change with abundant oil and gas fields. A relevant question might be, what do we do with the emissions? We measure at these oil and gas fields which are not in production anymore, but there still might be methane emissions, and still we might have to allocate them to certain countries because we would like to see a full picture in life cycle assessment. And so can be assumed that the burden on the remaining oil and gas users might be increasing more and more if the production of oil and gas is reduced. While we also would like to more cross-check global data with the country-specific data. For some data, like the US, there's a lot of data available on a country level side, on a well or oil field level side, but it's quite some work to compare these data because of, for example, different system boundaries, and which make it sometimes difficult to cross-check this data. Then it's of course important that other industries and Plastic Europe data integrate such information in their life cycle inventories, which they publish. The efforts also have to be coordinated with data for coal, and the PSI has done some work on this because there are also some methane emissions take place from this oil and gas, from this coal extraction, but it seems that the effect for coal is of lower relevance, and of course the coal also has a higher carbon footprint per energy content, and then of course it's not like natural gas direct source, but there's a little bit of natural gas stored also as a coal in the soil. Yeah, and this I can thank again all the organizations who have funded our work in the last 10 years, like the Swiss organization, like the oil producers in Switzerland, the gas producers in Switzerland, the database providers like CarbonMinds and ecoinvent, the Plastics Europe, and federal agencies in Switzerland, like the Federal Office of Environment and Energy, and also organizations of software providers, CE, which is related to CIMA-Pro. But as I said today, I presented my personal view on this and not this of the commissioners. Yeah, with this, thank you, and wait for the questions to come.
Yeah, great. Thank you so much. So we've got a few questions, but before I jump onto those, just a quick clarification. So in your slides, when you show the global warming potential, is this over a 100-year period? Because methane's impact is particularly more potent over shorter timeframes.
Yes, I think all the slides showed the global warming potential for 100 years.
Mm-hmm.
And part of the slides also the older version of 2013, because well, I didn't update the slides for this older data which have been published in 2018.
Yes.
And that's of course correct. And that's another discussion also, I would say, that should be taken in the LCA community. If the global warming potential 100 years is always the right thing to do, because if you look at the climate crisis, we don't have these 100 years to make decisions anymore. We have to make our decisions now in the next 20 years. We really have high challenges in the next 20 years to avoid tipping points of climate change.
Yep.
And these tipping points, we cannot somehow pull them back or repair them again by emission savings in the far future, I would say. And so this is a climate change effect we are causing, which takes place immediately, is a very relevant factor in the whole game. And that's, but it's of course not so easy to change this in the LCA community, where for a long time we thought, well, 100 years is the middle, we always take the middle, and then it's a good factor. It's of course a bit complicated where we should focus on.
Yes, absolutely. Okay, so jumping onto the questions from the audience. So could you comment on uncertainty in the methane measurement data that you are and ESU are using to update the LCI data imagery, particularly around satellite data? These tend to have quite high uncertainties just because there are a lot of assumptions made in the modeling to convert methane concentration measured by satellites into flow rates and fluxes.
Well, I think we are not experts on these satellite measurements, so we just took the data as they are. For some of the studies, we did comparisons between the different sources, and the relevant factor for us was this factor 10 between the old data and the new data. That we can say there's a factor 10 if we don't integrate it to the situation if we integrate it. But of course, like in LCA, you have these high uncertainties, and but I think this factor 10 is somehow a relevant estimate, and then I would not say it's accurate for, I don't know, 20% or so, and it's that's clear.
Okay. So in some of your earlier slides where you showed the GWP for oil and gas extraction, for some countries that don't have high natural gas resources, but they still have quite high GWP values, for example, Germany. Why is this?
For Germany, I think they have a very small production in Germany. So this might, of course, maybe also factor. I think this is a very small production. We did always allocate by the energy content of the extracted resources between oil and gas. So it's not possible to say, or because a lot of these fields are combined fields. Sometimes, of course, you just have gas or just have oil, but we cannot, for all these combined fields, we cannot say if it is, we can just make an allocation, I would say. And because of how the data sources come, we just can make an allocation between oil and gas based on the energy content, so that we have a total figure for the country. We allocate between oil and gas and between onshore and offshore. I think there it was also possible to differentiate, but yeah, we do not have like a physical relationship, I would say, like you call it an LCA, to assign this to oil or gas.
Yeah, okay. So someone asked a question about specific to gas transportation, specifically for pipeline transport. What kind of data did you use for diameters and pressures of the different pipelines, as they do vary by country?
And you mean, I think it's not clear if it is related then to the methane emissions or to the general LCA of a pipeline. I would say so far we did not do a major update on the pipeline infrastructure, and the pipeline energy use, and so on, because it was also of minor relevance. So this is, I would say, it's very average data we have for a long time in the database, and there's not a differentiation by diameters, by technical standard, and so on of these pipelines. It's really more an average.
Yes, okay. The eco profiles for Plastic Europe, do you know if these are also updated with the newest data that has been
yes, as I said, they are, the Plastics Europe, to my knowledge, they are not publishing like the version 2023, but they are focusing on a certain inventory and are updating this. So the data you find on the web page, they are from different, on the one side made by different consultants. They are sometimes made in different years and so on. And to my knowledge, the newer data have the background data of ecoinvent, and those automatically account also for these higher methane emissions, and some older data or by other data providers might not integrate this. But we did not work directly together with Plastics Europe to integrate the data, but just indirectly by delivering it to ecoinvent.
Okay. So follow-up question on the satellite data. It's a question about whether or not satellite data is verified, and also what sources do you take your satellite data from? I know there is the International Methane Emissions Observatory, which you can download data from, and also Kairos also have some data available, as well as GHGSat has data available.
I think in the meantime, we published 4 or 5 versions of these updates, and this changes from year to year, and this is mainly done by my colleagues, so I don't have it. I cannot tell this now for every year, but these are international organizations like the International Energy Agency, the World Bank, and so on. But well, to know it exactly now for the latest version of ecoinvent, you would have to read the report to understand which source has been used.
There's a question on the European Commission's product environmental footprint and how they are developing databases that are going to be released soon. Do you know if they will also be including these types of updates?
Well, I would say, to my knowledge, for the present data, I would assume it's not integrated because it's also delivered by Sphera and old and cumulative and so on. So the data quality of these present data, to my knowledge, is very low. We have not been in direct contact with the EU about this. And I know that there's now an ongoing project for updating the data. For example, consultants is involved in it, but I don't know about the actual plans, what they do about it. I would say they are informed about this issue, but how they deal with it and what they will do, I don't
know. So going back to the topic of methane emissions, so something that is quite common in the methane emissions research and data that's collected is you have something called super emitters, where you'll have some which really tend to like skew what average methane emissions are estimated to be for a facility or for a supply chain. How are these factored in the methane emissions updates that ESU have been applying for oil and gas extraction and as well as for oil and gas use?
I'm not sure if I understood. So you said super emitters or so.
Yes.
I would say I have not heard about it before.
Okay.
Well, what we do is, because the statistical data are available on a country basis, and so we also establish the data based on a country basis, and we relate the methane emissions which are allocated to a certain country to the oil and gas production in this country. That's the way how you can go. Of course, you could also discuss, for example, if you can do it on a company-based level or something like, or a technology-based level, like what you said with the fracking or advanced oil and gas extraction. But these methane data and also other statistical data are in the moment not available on such a grade of detail, I would say.
Yes.
And
Okay.
but the other thing what I've heard is that, well, with the satellite data, it's possible to identify the source of emission, so that, well, interested companies or legislators or so on, they could identify the source and go to the site and then try to identify, to close the hole, I would say.
Yeah, okay. So you talked about how data availability is a very big challenge in terms of updating these data sets. Are there any particular you mentioned Middle East and Africa. Are there any specific countries that you are hopeful will be able to publish data in the future, just because they could potentially be important sources of methane and important for these different supply chains that use oil and gas?
Well, that's of course one of the challenges with
Yeah.
these industries that, well, of course, I would say in the US so far, the situation was good with data availability, also in the European countries like Norway, Netherlands, United Kingdom, and so on. But these countries are not so relevant anymore. Only Norway still has some reserves, to my knowledge, but I think the other countries, they are more phasing out the production. And then all this gas and oil extraction today takes place in countries with very difficult political situations, I would say.
Yeah.
And that's of course also a major challenge for this, to getting on-site data or data somehow verified or measured by governments and so on. And my feeling is that of course, there's some responsibility by the oil and gas companies, but as I said, in the last updates, we found it very difficult to use the data published directly by certain companies for such work, because they somehow accumulate or aggregated often over different countries or different stages of the supply chain.
Yes, absolutely. So someone has asked, so we have 2 more minutes left, so we'll make this the last question. So someone has just asked, to which extent is the inclusion of methane emissions of crude oil extraction expected to affect the production of fossil-based plastics, and whether or not it's expected to be significant? Because
yes, this I presented at the beginning.
yeah,
that
you did, yes.
About increases the carbon footprint about 15 to 30% of the plastics. So if you look from cradle to gate, not burning the plastics at the end, then it can have a relevant effect on the carbon footprint.
Okay. So you answered that fairly quickly. I'll sneak in one more question, which was asked by the audience. It's not entirely directly related to your presentation, but you talked about fossil methane, but biogenic methane is also important. And so someone was asking how well land use related impacts and land methane from land use change and biogenic methane. Do you have any thoughts on how these will be updated in future databases?
No, and I'm not sure if it is. Well, what I understood is that, or to my understanding, it's possible to differentiate between the biogenic and the fossil emissions with these measurements, so that it's not, the cows are not playing into the game. But I have not yet heard that it is somehow used to identify, for example, the emissions of the cows. And I think that's also, I would say, it's good known that cows are emitting methane, and I guess it's more easy to measure this on ground and not say, okay, you have in the US, in this sector, you have a lot of cows, so we have a lot of methane emissions there. I have not heard that it is used in this way.
Okay. But do you think it would be possible to potentially see more measurements of this type being collected and then integrated into LCI data? Because for quite a few countries, agricultural-related methane is the primary source of methane rather than oil and gas.
Well, I'm mainly interested in this life cycle assessment. I think it could play a role, for example, for the country-based reporting to the IPCC. Of course, there it would be helpful if you could say, well, in this country, we have this amount of methane emissions coming from cows and biomass and so on, and you could integrate this in your inventory. This would somehow facilitate the work. I think for doing the normal LCA of a cow, it's normally maybe more easier to take, like the models we have for it.
Yeah, okay, absolutely. That is absolutely, absolutely agreed. So we are out of time. So I'd like to thank you, Niels, on behalf of the network and our attendees. It was a really wonderful seminar and really insightful, and it's really great to get an insight into just how these types of data sets that we all use are created and updated. It was really wonderful. So thank you so much.